In this video, I'm going to show you how to do Edexcel A-Level Maths from June 2023, Paper 1, Question 15. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. Please like and subscribe. Now, question 15 is a rather long question, so it runs to, the whole question itself covers a full page and the answer will run to several pages. So what I've done is I've split the question up into multiple bits, and we'll look at each bit separately. Okay, so the first part of the question here is a curve has equation y equals f of x, where f of x is given by this formula, 7x e to the x divided by the square root of e to the 3x minus 2, and x has to be greater than natural log of the cube root of 2. And part A says show that f dash of x, the derivative, is given by this rather complicated formula which I won't read out, where a and b are constants to be found. Okay, so what we have here is a quotient, so we use the quotient rule for differentiation. I'm going to use the letters f and g. Some people will use u and v, although we've actually got an f here, but normally we would use f and g. So the top of this we call f, which is 7x e to the x. So if we differentiate it, that will give us f dash. Now this is two expressions multiplied together, so we can do that using the product rule. First of all, differentiating 7x gives us 7, and we leave the e to the x alone, so 7 e to the x. And then we do it the other way around. We differentiate e to the x, which gives us e to the x. So it will be 7x e to the x, and we can factorize out a common factor of 7 e to the x. So it will be 7 times e to the x into 1 plus x. Now the bottom here, which we're going to call g, is the square root of e to the 3x minus 2, which we could write as e to the 3x minus 2 all to the power a half, and we can differentiate that g dash by using the chain rule. So bringing the half in front, differentiating the inside, e to the 3x will become 3e to the 3x, and then the reducing the power by 1 here will be e to the 3x minus 2 to the power minus a half. Now the derivative here is going to be f dash g minus fg dash over g squared. So in this case, f dash of x will be equal to f dash g, so it will be this expression here, 7 e to the x times 1 plus x times g, which we've got here, e to the 3x minus 2 to the half, all right, minus g minus fg dash, so f is 7x e to the x, g dash we've got here, it will be half times 3 e to the 3x, and then e to the 3x minus 2 to the power minus a half, all over g squared, which is this expression here. If we square it, it will be e to the 3x minus 2 to the power half. Half times a half for indices adds up to 1, so it will be e to the 3x minus 2 on the bottom. Now, there's a bit of a clue here. If you look at the version, they've got e to the 3x minus 2 to the power 3 over 2. So it's a half a power higher. So, and you also know there's a minus a half in there. So the first thing I'm going to do is multiply everything by e to the 3x minus 2 to the half, top and bottom. So now we're going to get f dash of x is equal, this will become 7 e to the x 1 plus x e to the 3x minus 2 to the power 1, so I don't need that anymore. And now here, this I can simplify slightly, or I can write this as, what I'm going to do is take this inside, so it'll be minus 7 here, and I'm going to combine these all together here. So it will be 7, 3 over 2 for the constant. There'll be this x here, and then there'll be an e to the x and an e to the 3x. E to the x and an e to the 3x. And because I've multiplied by e to the x to the power half, this will be to the power 0 or just 1. And on the bottom here, I will have e to the 3x minus 2, and I've multiplied by e to the 3x minus 2 to the power half, so now it'll be over to the power of 3 over 2. Yeah. Okay. Now I might notice that there's a 7 e to the x in both halves of this expression, so I can take that all out. So 7 f dash of x is 7 e to the x. I'm putting nice big brackets around it here. I've got 1 plus x times e to the 3x minus 2 here. And then I've taken out 7 e to the x here. So I've got minus 3 over 2. I've taken out the e to the x, but that x is still here. So I've got x e to the x, e to the 3x, e to the 3x, after I've taken out that e to the x. And then on the bottom here, I still have the same bottom, e to the 3x minus 2 to the power 3 over 2. Now, the next thing I'll notice is here, they have a 2 on the bottom. So what I need to do is times the bottom, the top and bottom by 2. Yeah, and actually what I will do is actually expand this bracket out here on the top first. Yeah. So this will be f dash of x is 7 e to the x, and then on the top I'll have 1 times e to the 3x, so e to the 3x. Then I'll have 1 times minus 2, so minus 2. And then I'll have x times e to the 3x, so plus x e to the 3x. And then I'll have x times minus 2, minus 2x. And I've still got this other part here, minus 3 over 2 x e to the 3x. Yep. And then it's still the same bottom, e to the 3x minus 2 to the 3 over 2. And now what I can do is I can simplify the top a little bit, because I can see that several of these have got an e to the 3x in them. So I can say f dash of x here is 7 e to the x, and then I've got, how many e to the x's are here? I've got I've got 1 e to the 3x, and I've got minus a half of x e, because there's one lot of x times e to the 3x, and minus 1.5 of x times e to the 3x. So I've got minus a half of x to the times e to the 3x. So minus a half of x times e to the 3x here, right? And I've also got a, I need another bracket here. I've got another minus 2x minus 2 over e to the 3x minus 2 to the 3 over 2. Now the last thing I need to do is take out this e to the 3x and times everything, say everything inside this bracket, by 2, top end, and I'll time the bottom by 2 as well, so it stays the same. So it'll be f dash of x is 7 e to the x times, so this one, remember I'm taking out an e to the 3x as a common factor here, so that will be e to the 3x, and then here of these two, and I've doubled everything, so it will be this was a 1, but it will be doubled, so it will be 2, and this was a minus half x, so doubled would be minus x, yeah, and then so e to the 3x times 2 minus x, and I've got to double these as well, so minus 4x minus 4, and on the bottom now I've got 2 e to the 3x minus 2 to the 3 over 2. So you can see that my constants a A is minus 4 and B is minus 4 as well. So that completes part A of the question. It's rather a messy set of algebra. I'm sorry about my handwriting. Okay, I'll probably space it out a little bit more in the actual exam because I wanted to fit it onto one page here. Okay, so now let's move to the next part of the question. Right, so we now have 15 part B, which is here. It says, hence show that the x-coordinates of the turning points of the curve are given by this equation. So we already knew that the top of the equation, it was given in part A. You could do this even if you hadn't managed to do all that algebra. F dash of x is equal to 7 e to the x times e to the 3x times 2x, 2 minus x. And remember, we found those constants a and b, so minus 4x minus 4, and then all over 2 times e to the 3x minus 2 to the 3 over 2. Now, at the turning points, f dash of x is equal to 0, which means the top has to equal 0. So we have 0 is equal to 7 e to the x, e to the 3x, 2 minus x, minus 4x minus 4. Okay? So we need to just rearrange this to make x the subject. Okay? So first thing is that 7e to the x can never be 0. Yeah? So it's got to be this factor, because there's two factors here, 7e to the x and this rather complicated factor in the brackets, and 7e to the x can never be 0. So we know that this tells us that 0 is equal to e to the 3x, 2 minus x, minus 4x minus 4. So what we now do is expand out all our x factors. So we're going to say, let's write out 0 is equal to 2 e to the 3x minus x e to the 3x minus 4x minus 4. Okay? And what we'll do is we'll bring the factors that don't contain x to one side and the other ones to the other side, and then we can factorize out x. Okay, so which will be the easiest way to do this. We want a 2 to the 3x minus 4. Okay, well let's do this as we'll bring these two over the other side here. So we'd have x and then e to the 3x minus 4 on the left-hand side, because this will expand to these two middle terms, is equal to 2 e to the 3x minus 4. And then if we divide by this, we'll get x is equal to 2 e to the 3x minus 4 divided by e to the 3x. Oh, sorry, that minus 4 should have turned into a plus 4 there. Plus 4, because we took it over the other side. And that completes part B of the question. Part C of the question is another long section. I'm actually going to have to move the paper around a little bit to do part C. The equation x is equal to e to the x minus 4 over e to the 3x plus 4 has two positive roots, alpha and beta, where beta is greater than beta is greater than alpha. A student uses this iteration formula. Xn plus 1 is equal to 2e to the 3xn minus 4 over e to the 3xn plus 4 to find approximations for alpha and beta. Diagram 1 shows part of a plot of the curve with this equation and part of the line y equals x. Using the diagram on page 42, which is going to draw a staircase diagram to show the iteration formula starting with x equals 1 can be used to find approximation of beta. So if you were using the staircase diagram, what would happen is you would go up from 1 and then you would go across, and then you would go up, and then you go across, and as you can see, you get closer and closer to beta. So that's how you would reach a approximate value for beta. You'd gradually converge on it. Okay, so that was relatively easy. Part D, using the iteration formula with x1 equals 1, to find 3 decimal places the value of x2, and part 2, the value of beta. So what you do is you type in 1 in your calculator, press equals, so store it as the answer, and then you type in y. I'll write it out what you type in. Y is equal to 2 e to the 3 times answer minus 4 over e to the 3 times answer plus 4, and if you press equals, that will give you x2. And you will find that the value of x2 is approximately to 1.502 to 3 decimal places. So that's D1. And if you continue doing it, eventually the value will converge. So you can find that beta is approximately equal to 1.968, I think, to 3 decimal places, and that completes part D. And lastly, part E, using a suitable interval and a suitable function that should be stated, show that alpha is 0.432 to 3 decimal places. Remember, alpha is the solution when the for this iterative equation. So we're trying to solve for part E, x is equal to this. So what we need is that we need to set up a function where where the root of the function is equal to 0. So what we do is we take that over to the other side. So we're going to say h of x is equal to, or we could take this to the other side, whichever way around. Let's do it as x minus 2e to the 3x minus 4 over e to the 3x plus 4. And we want to find solutions. So we're finding h of x is equal to 0. So what we can do is we can do h of 0.4315 and h of 0.4325. And if we do that, h of 0.4315 comes out to 0.0002974, which is ever so slightly positive. If we do the other one, we'll get minus 0.000, and I think it's 9479, which is ever so slightly negative. And because it's a continuous function, it must cross over the x-axis. So the answer is, so beta is approximately equal to 0.432 to 3 decimal places, because we know it's between these two values, because h of x is continuous and there is a sign change between 0.4315 and 0.4325. Sorry, it's gone off on the right hand side there, you can see it there. Okay, and that completes question 15.